So starting off with section 4.2, we're going to be dealing with two theorems within this section, Rolle's theorem and the mean value theorem. And so this first example we have is dealing with Rolle's theorem, and this theorem is we're trying to find when velocity equals 0. So we have our equation f of x equals 2x squared minus 4x plus 9 within the domain -1 to 3. So in order to use Rolle's theorem, we need to meet 3 criteria. So the criteria is the equation is continuous, differentiable, and if f of a equals f of b. So we know that it's continuous because it's a polynomial, and we also know that it's differentiable. So now we just need to test that f of a equals f of b. So how we do this is plugging in both the endpoints into the equation and seeing if they equal each other. So first off, if we plug in 1, so we have f of -1, this equals 15. And our other endpoint is 3, so f of 3 also equals 15. So we can check off this criteria as well. So Rolle's theorem is dealing with velocity. So this initial equation we're given is position. So we need to take the derivative in order to find the velocity function. So we have, to take the derivative, we have f prime of x equals 4x minus 4. And then we're going to set this equation equal to 0 because what we're trying to find is when velocity is equal to 0. So we have 0 equals 4x minus 4. So this is pretty easy. We have 4 equals 4x. And then we just divide each side by 4. So we have x equals 1. So this is our answer. And what our answer is telling us is that at the point x equals 1, that means that the velocity is 0, and x equals 1 is satisfying Rolle's theorem. So that second theorem we're going to be talking about is the mean value theorem. So we also, for this equation, for this theorem, we also have 2 criteria that need to be met in order to use mean value theorem. And if these 2 criteria aren't met, then we can't use the mean value theorem. So we need to know that our equation is continuous and differentiable. So if we take a look at our equation, we have f of x equals 4x squared minus 3x plus 2. So since this is a polynomial, it's continuous and it's also differentiable. So for the mean value theorem, what we do is we take the slope of the tangent and set it equal to the slope of the secant line. So the slope of the tangent line is just a derivative. So if we take the derivative of this, we get f prime of x equals 8x minus 3. So that's our slope of the tangent, and our equation that we use for slope of the secant is f of b minus f of a over b minus a. And so when we plug this in, so f of 2, so yeah, this is our a, and this is our b. So f of 2 comes to be 12, and then f of a is 2, so we have 12 minus 2, all over 2 minus 0. So this comes out to be 10 over 2, or 5. So just to reiterate, this is our slope of the secant line, and this is our slope of the tangent line, so we're going to set them equal to each other to find out what value satisfies the mean value theorem. So we have 8x minus 3 is equal to 5. So we add the 3 to each side, so we have 8x equals 8, and then we end up getting x equals 1. So x of 1 satisfies the mean value theorem, and we know it satisfies the mean value theorem because it is the slope of the tangent set equal to the slope of the secant, and also because it's in our interval. So if this value turned out not to be within our interval, then it would not satisfy the mean value theorem.